Hi everyone, so this is tutorial sheet 2, question 16. Yeah, I remember I answered the first question here. You find it on the channel there. It's there. So I answered A, meaning in this tutorial I'm just going to answer the remaining ones here. Okay, so we start. So I'm going to start with B. B is saying 1 minus, this is tan squared alpha, and everything divided by 1 plus tan squared alpha, and then everything equated to cos 2 alpha. So when you look at the denominator here, then you check your identities, you discover to say tan squared a plus 1 is nothing but sec squared. So where there is tan squared alpha plus 1, we're going to replace with sec squared theta. So this is what we're going to do. So this is tan alpha, then here we replace it with sec squared alpha, then this is equal to the left hand side. And then now when we know to say this again can be written as 1 minus our tan alpha there, this is supposed to be squared. Our tan alpha can be written as sine squared alpha, then everything over cos squared alpha. Then we put them in brackets, divide by sec theta, but we know to say sec theta is nothing but 1 over cos squared alpha. So this one can also be written as, so if you are dividing, we know the rules of division. You change the sign here and then you swap these here. So what I'm trying to say is this. You change the sign to multiplication and then swap these. Instead of it being 1 over cos squared x, we're going to have cos squared x, cos squared alpha over 1 being equal to the left hand side. So this now, you're going to have, when you multiply this cos squared alpha times cos times 1 this side, you have your cos squared alpha, then minus cos squared alpha times this, you are going to have this cos squared alpha and that cos squared alpha to cancel, meaning you're just going to remain with sine squared alpha. Then sine squared alpha, cos squared alpha minus sine squared alpha, we know to say it's just nothing but cos 2 alpha. So this is just the same as cos 2 alpha. So we have proved this identity. We move on to the next question, which is this one. Cot theta sine 2 theta is equal to 1 plus cos 2 theta. Let us try to see how we're going to solve this. Alright, so we move on to C. So for C, you first need to put in mind that this 1 plus cos 2 alpha, cos 2 theta there can be gotten from from the double angle formula for cos to alpha, for cos alpha or cos theta. So cos theta, so we know to say cos 2 theta is given by 2 cos 2 cos squared theta, then minus 1. So meaning for us to get this, it means that they made this the subject. So they made 2 cos squared theta as a subject, meaning this is what they did. So we're going to have 2, and we're going to have cos 2 theta, and then plus 1. So this is what I did for them to get that. So we now start solving our question. Our question is there, cot. We know that cot theta is just nothing but 1 over tan, which is cos over sine. So cot theta, let me just copy the question, then sine 2 theta. This one is equal to LHS, the left hand side, and then you also now change this. So we know that cotangent of theta is nothing but cos theta over sine theta. So cos theta over sine theta, and then you're multiplying this by 2 sine. We know sine 2 theta, the double angle formula for sine 2 theta is sine 2 sine theta, and then cos theta. Like that. So this is like that. I was just trying to separate that, and then so this is equal to the left hand side. Okay. So now when you look at this, when you multiply this times that, it's just the same as cancelling this and that. And then when you cancel the 2, means that you're going to remain with 2 cos theta times cos theta, which gives you 2 cos squared theta, being equal to the left hand side. So now when you look at 2 cos squared theta, this is what we just got here, which is this part. So where there's 2 cos squared theta, we can replace with cos 2 theta plus 1. So here we can put 1 plus cos 2 theta, and hence proved. So we have proved this identity. This is the solution for C. So these questions are as simple as this. You don't have to struggle. Let's move on to the next question. So for D, as usual, when solving identities, you start with the complicated part. So the complicated part is this. So this is the one that we're going to put as our right hand side. So cos squared x, sec squared x over 2 minus, so I can change this in advance over, so sec squared x is just the same as cos squared 1 over cos squared x, like that. I've just changed it in advance, is equal to my right hand side. So when you find the common denominator here on the denominators there, when you find the common denominator, you are going to have, first let me write the numerator, sec squared x over, find the common denominator there, you find it to be cos squared x. Then there you are going to, when you multiply 1 into, first when you divide 1 into cos x times 2, you have your 2 cos squared x, then minus cos x into cos x squared, you get your 1 times 1, you get your 1 there, then put them in brackets like that, is equal to the right hand side, so from there we can now say this 2 cos squared x minus 1, we know that it's just nothing but cos 2x, so we can write it as sec squared x, then everything divided by, so the numerator there is giving us cos 2x. So they want us to reach this they want us to change this, they want it to look like the one which is on the left hand side there, so they want the right hand side to look as exactly as the right hand side, the left hand side. So this is what we are going to have. Apart from that, here the denominator is divided by cos x, so in other ways we can write this as sec on top there, sec squared x, and then everything over. This can also be written as 1 over cos squared x, then multiplied by cos 2x, which gives you the right hand side. Right, let's move, let's see what we can do. So from there you can also, so you can see to say 1 over cos here is sec, so I can write my sec squared on top, then everything divided by this part here is also sec squared x. Then I know to say this, I'll just write it the way it is, cos 2x being equal to the right hand side. So this and that will cancel, so meaning what I'm going to have, I'm going to remain with 1 over cos 2x, which is equal to the right hand side. And apart from this, we know to say 1 over cos is nothing but sec. Since the angle here is 2x, so we're going to have sec 2x being equal to the right hand side. Hence proved. So we have proved it as well. Let's see what we can do again. But I think these are a lot, because the remaining ones are straightforward. Yeah, the remaining ones are straightforward. Let's see, maybe we just finish all of them. Okay, E. But again, anyway, let's finish E. E is cot. I want us to prove that cot 2 alpha is equal to cot squared alpha minus 1, then everything over 2 cot alpha. So first of all, we can divide this cot into cot and this cot into 1. So meaning I'm going to have something like this. So 2 cot alpha into cot alpha there. You're just going to remain with 1 cot alpha on top. And then everything divided by 2 minus 1 over 2 cot alpha. Yeah, like that. So next step here, what we're going to do is we know to say cot alpha is just nothing but cos alpha over sine alpha, which is, and then we don't forget to put the 2 there, and then minus, we know to say 1 over cot alpha is just the same as tan, which is just the same as sine alpha over cos alpha. We don't forget to put the 2. So from there we can now find, when we find the common denominator here, will be 2 sine alpha cos alpha, 2 sine alpha cos alpha, and then this into that, you get cos times cos, you get cos squared alpha minus, you divide that into that, and then you get your sine times sine, you find your sine squared alpha. So when you look at the numerator there, the numerator is nothing but cos 2 alpha. So the numerator is just the identity for cos 2 alpha, and then the denominator, that's the identity for sine 2 alpha. So when you look at the 2, you agree with me that this is nothing but cot 2 alpha, and hence proved. Let's move on to the last question. So the last question is, I think I'll just write it here if it's not that long. Okay, the last question is cos 2 alpha, or cos 2 theta, sorry, and then divide by cos theta plus sine theta. So first of all, when you have such a question, this is question F. So when you have such a question, you multiply it with its conjugate. So the conjugate will be cos alpha or cos theta plus sine alpha. So the conjugate is going to be minus here. We're going to put a minus there. So we're going to have cos theta minus sine theta, like that. Then you also put the same conjugate on top, which is cos theta minus sine theta. So now the denominator there tells us to say it's a difference of 2 squares, which can also be written as cos squared theta minus sine squared theta. So having done that, we can now simplify the top part there. So the top part there, we know that cos 2 alpha, we just leave it like that without simplifying it. This is cos 2 alpha, and cos 2 theta. Then we're going to have cos theta minus sin theta. Like that. So we know that the denominator here is just is nothing but the identity for cos 2 theta. So we write cos 2 theta there, which is on top, and then you write this cos theta minus sin theta in brackets like that, and then everything divided by cos theta. Everything divided by cos 2 theta, because we know that the identity for cos 2 theta is just this down there. So this and that can cancel, meaning that the only thing that we're going to remain with is the top part there, which is cos theta minus sin theta. Hence proved. We have proved the identity. So thank you very much for watching. Make sure that you don't forget to subscribe to the channel. If you have any questions, contributions, you make sure that you send it on this WhatsApp line, which is on the screen right now. See you in the next tutorial video.